Yes, earlier problem ಏನು ಮಾಡಿದ್ರಲ್ಲ ಇದಕ್ಕಿಂತ ಮುಂಚೆ what problem we have done, the same method we will adopt, the same method. What I have done, R1 changes to R1 minus R2 minus R3, because everything is same. Instead of B we have B square, instead of C we have C square, instead of A square we have, and everything is same as what we have done in the earlier problem. So same method only we will follow. So I will change R1 changes to R1 minus R2 plus R3. What is R1? We have B square plus C square. This I am changing with minus B square, because R1 is changing with R1 minus R2 minus R3. First row yellow, A square minus of C square plus A square minus of C square. Next, A square minus B square. Okay, I am subtracting with the B square. Next, see R1, this is R1 minus R2 minus R3. So similarly A square, subtraction of this one, even subtraction of this one. Then A square minus B square minus of A square plus B square. Okay, right? See, almost board I took. Now, so B square, C square minus B square minus C square. A square minus of C square plus A square minus C square. A square minus B square minus of A square plus B square. So similarly, I didn't mention anything about the second row as well as third row. That means I am not changing the second row, I am not changing the third row. That means I need to keep as it is only. So B square, C square plus A square, B square. Next, C square, okay, A square plus B square. Right, up to this. Right? Still, that's all I think you can see. What I will write is here B square, positive B square, negative B square, positive C square, negative C square will get cancelled. I will get 0. A square, see, minus into plus, minus. C square, minus into plus, minus. A square, minus C square, as it is. This is A square minus B square minus A square minus B square. I hope you can see up to this. Next, B square, C square plus A square, B square. So C square, A square plus B square. See, A square positive, A square negative, cancel. A square positive, A square negative will get cancelled. Same method what we have done for the earlier problem. So I will get 0. I will get minus 2 times of C square, minus 2 times of B square. B square, C square plus A square, B square. C square, A square plus B square. In the first row I can take minus 2 common. Remember the earlier problem. 0 can be written as minus 2 into 0. 0 can be written as minus 5 into 0. For the convenient, what I will write? 0 can be written as minus 2 into 0. So that means I will take minus 2 common. When I take minus 2 common, this is 0. C square, B square. Next, B square, C square plus A square, B square. C square, A square plus B square. Right up to this. See, I am changing only second row. As well as third row. I am not changing the first row. That means I need to keep first row as it is. 0. C square as well as B square. How I am changing second row? I am changing the second row by subtracting it the first row. B square second row. C square plus A square second row. B square second row. How I am doing? I am subtracting that with the first row element, minus 0, minus C square, minus B square. Similarly, third row. What is third row? C square. C square. A square plus B square. How I am changing third row? I am changing third row by subtracting with first row. Minus 0, minus C square, minus B square. So minus 2, 0, C square, B square. This will be B square as it is. C and C will get cancelled. I will get A square. B square minus B square is 0. C square. This is also 0. This is, I will get A square. So plus, minus, plus. Determinant. So minus 2. I told you need not take a 0. Minus C square. So when I take C square, I need to eliminate the row and column related to that. I will get B square, 0, C square, A square. Plus into plus B square. When I take B square, I need to eliminate this row as well as this column. I will get B square, A square, C square, 0 square. B square, A square, C square, 0. Sorry, correct? 0. Okay. Now, minus 2 as it is. Minus 2 as it is. This is minus C square. Minus C square. The product of principal diagonal minus the product of secondary diagonal. B square, A square is nothing but what? A square, B square. I will not write because C square into 0 is C square. No need to write. Then plus B square. Again B square into 0. 0 minus A square into C square. A square, C square. Yes. Now, this is minus 2, minus into plus minus, C square, A square, B square is A square, B square, C square, plus into plus, okay, B square into 0 is B square, 0 only, plus into minus, B square into A square, B square, C square. So, this is minus 2. Minus A square, B square, C square one time, another time, so minus 2 times of A square, B square, C square. Minus into minus plus 2 times is 4, A square, B square, C square. So this is the required proof. Yes, please copy down this one. Now this is, in this question it is very clear, he told you solve, not prove. If they ask you to prove or if they ask you to show, you should show left hand side is equal to right hand side. When he asks solve means you have to find the value of x. Solve means what? You need to find the value of x. It is not proof. Sir, left hand side ಕೊಟ್ಟಿದ್ದಾರೆ, right hand side ಕೊಟ್ಟಿದ್ದಾರೆ, ನಾನು proof ಕಂಡುಹಿಡಿತೀನಿ ಅಂತಲ್ಲ. ಒಂದು ವೇಳೆ proof ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ will tell that, prove that, show that ಅಂತ ಕೇಳಿದ್ರೆ then you have to show left hand side is equal to right hand side. He didn't mention, he told solve. Solve means what? You need to find the value of unknown. In this case, x is unknown. All others we have a number. So how we can solve? By using the property only. You check. Suppose if I add, how much I will get? X plus 2 plus 2 plus 2. X plus 6. I am adding row wise. If I add, I will get x plus 9. If I add, I will get x plus 12. X 4 plus 4 plus 4, 12 plus x plus 12. So when I add, what happens row wise? When I add row wise, first row, second row, third row, I am adding first row to the second row, second to the third row. When I add, what happens, we'll get some values, but there is no possibility of taking common. There is no possibility of taking common. When you are adding or subtracting the row wise or column wise, it should help us to take something common. So it is not possible. So row wise it is not possible. I will take column wise. If I add, how much you get? X plus 2 plus 3 plus 4. I think 3 plus 2, 7, 9. Again if I add 9. If I add, I'll get 9. That means I need to change first column changes to first column plus second column plus third column. What is first column? X plus 2. 2. For this what I am adding? I am adding second column 3. I am adding second column x plus 3. I am adding second column 3. Further I am adding third column plus 4 plus x plus 4. I am changing only first column. I am not changing anything else. That means I need to keep second column as well as third column as it is. How much I will get with this? X plus 7, 9. X plus, if you count also I will get 9. X plus 9. So 3, x plus 3, 4, x plus 4 is equal to 0. In the first column I can take x plus 9 common. If I take x plus 9 common, what I will get? If I take x plus 9 common, I will get 1. I will not get 0. Remember, x plus 9 is nothing but 1 time of x plus 9. 1 time of x plus 9. So if I take x plus 9 common, I will get 1. So I will get 1, 1, 1. So 1, 1 of course, 3, 4, x plus 3, 4, 3, I will get x plus 3. What I will do is, I will change x. What I will do is, I will change second column changes to second column minus first column. Notice subtract this 0. This 0. Right? Then this 3 this 0. Even this 0. This kuda 0. So similarly, I will change third column changes to third column minus first. X plus 9. Sorry, row wise. I am changing the row wise. First row as it is. What is second row? 1, x plus 3, 4. I am changing second row. How? By subtracting with first row. Minus 1, minus 3, minus 4. Yes? Now, 1 minus 1, 3 minus 3, x plus 4 minus 4. I have changed third row with first row. Right up to this. Yes. Now what I will get? X plus 9, 1, 3, 4, 0, x. These two will give 0, 0, 0. It will give x. Right? Now see, according to the property, this is the principal diagonal. According to the property, the elements below the principal diagonal are 0. The elements below the principal diagonal are 0. Therefore, what you need to do is you need to multiply the principal diagonal elements. So, according to a property, otherwise I will write here, don't worry. Okay, I think you can't see. I'll write here, according to a property, elements below principal diagonal are 0. So therefore, multiply principal diagonal elements. So therefore, what I will get? 1 into x into x. Principal diagonal 1 into x into x. As usual, we have x plus 9 is equal to 0. So very clearly, x plus 9 is equal to 0. X plus 1 into x is x square is equal to 0. Right? Because x plus 9 is equal to 0, x square is equal to. Therefore, x is equal to minus 9, x is equal to plus or minus root 0, x equal to. So we got x equal to what? Minus 9 as well as 0. So these are the two solutions. Right? These are the two solutions.